Today we are looking at lesson 3-4. So I apologize, I still have my cold. So 3-4 really deals with fractional exponents. So it's really more of a study thing where you have to really study the process of converting a base with a fractional exponent, which is called exponential form, into its radical form. So this is an example of a base with some sort of fractional exponent. So all that happens is when we have these rational exponents, it means that the base is under a radical of some sort. So this base A is right here, and if you cover up this bottom number n, it looks like a to the m. Notice that a to the m is underneath here, and then n becomes the index. So the denominator of whatever this fraction is always is your index, and then the base in that numerator becomes the base in power underneath the radical. So you might want to write yourself a note to that effect, that this is your index or your root. This is still the base. And then this is the exponent the base is raised to. Okay. We'll talk about what this means here in a minute, but let's look at an example that happens to have a variable. So we have x raised to the 1/2. This 2 is the index for here. So remember that when we have an index of 2, you don't ever see it. It's understood it's a square root. Then if you cover this up, you see an x to the first. So an x to the first goes underneath here. Then let's look at just one more. If I had 2 to the 3/5. Okay, so 2 is my base, 5 is that index, so I'm going to take a 5th root, and if I cover that up, I've got 2 to the 3rd. So I know I'm going to have some index. I know that my index is the denominator of that fraction. So I know that that denominator always goes here. So then if I cover that denominator up, I see 2 to the 3rd. So I'm going to write 2 to the 3rd underneath here. Then since I cannot take 5 and divide it into 3, it doesn't go in there evenly at all, I do need to then multiply out that 2 to the 3rd. So 2 to the 3rd is 8. So we end up with the 5th root of 8. Now, if the directions are saying just convert this to its radical form, I will accept this, I will accept this. So either one will be correct. So let's look at some more conversions. So for this side, we are going to convert radical form to exponential form. So equals, I know that my base is going to be c, because the base under the radical and the base in exponential form aren't going to change. So my base is c, and I have some fractional exponent that's going to go here. Well, 100% of the time the index is in the bottom, so put that index in the bottom, and that only leaves one place for the power of the base to go. In this case, -5 is going to go up here. So it's c to the -5/3. Now I want you to pause the video and I want you to try this one on your own. All right, so you've got z as your base, and then that 4 is going to go in the denominator of the fraction. So here's my fraction, and it's got a 4 underneath. And then because z is actually raised to the first power here, so this is z to the first, that 1 is going to go there. So the 4th root of z is z to the 1/4. All right, so then let's move this over and let's go in reverse. So now I'm giving you the exponential form, and I want you to put it into radical form. So I will do the first one with you. So equals And I know that I'm putting in radical form, so I have some sort of radical here. 100% of the time, that bottom number is going to go here on the radical. So the 5 goes here. And then when you cover up that 5, you see a to the first. That's what goes underneath the radical. So a to the first goes underneath here. We typically don't write anything to the first power, so the real answer is the 5th root of a. But if you wrote the 5th root of a to the first, I'm not going to mark you off for that. Now pause the video and do x to the 7/4 on your own. Okay, so we know that x is under a radical, and I know that the denominator is going to be my root, so I get the 4th root, and then if I cover up that denominator, I see x to the 7th. So x to the 7th needs to be underneath here. And technically this can be simplified, but the directions are just to convert. So since we're converting, you don't have to go the extra step to simplify. Now if it said simplify, then we would have to go through the next step and simplify the 4th root of x to the 7th. So in this problem, there are no directions, so I'm going to give you the directions. Actually, okay, so your directions here are going to be to simplify. Now I'm going to give you 2 different ways to do this, and you'll prefer one way or another. The first way that I'm going to show you is my preferred way, but there is a second way. So we're going to term this as way 1. Okay, so you're going to see some familiar numbers here. So we've worked a lot with 125, 32, and the other one is 16. So we prime factored a lot of these in 3-1. Okay, so we are going to change that 125 into its prime factored form. So remember, when you prime factor the 125, and I'm not going to do this for every one, you have the prime, I'm doing it upside down. So, okay, so some of you aren't going to like this. So I'm going to backtrack here. So if I took 125 and I prime factored it, 5 goes in there 25 times, 5 and 5. So remember, we did all of that in 3-2 when we were simplifying radicals. So I know that 125 has 1, 2, 3 5s in it. So my hope is that you remember a lot of these popular numbers that we've used. And if you don't, then you're going to have to prime factor it just like I showed you. So the 125 can be converted into 5 to the 3rd, and that is raised to the 4/3. Then remember, this is a power to a power. Power to a power, we multiply exponents. So we're going to take 5 to the 3, and I'm going to put 3 over 1 because I'm multiplying it to a fraction, times 4/3. So for those of you who don't know how to simplify a fraction before you multiply, remember you can cancel out these 3's. And then you just have 4 over 1. That's really the shortcut, the proper way to do it. But I know that a lot of you don't know that. So I'm going to multiply straight across and straight across. So 3 times 4 is 12. 1 times 3 is 3. So 12 divided by 3 is 4. So either way that you think about it, you're going to get 4, but technically that's the way you should be doing it. And so I get 5 to the 4th. You actually have to multiply out 5 to the 4th. So 5 times itself 4 times is 625. Use a calculator if you don't know how to do it. All right, so that's way 1. Now way 2 is converting, way 2 is converting into radical form. Okay, so I'm going to convert 125 to the 4/3 into its radical form. So we know that it's under the radical, and we know that this is the index that goes here. So I've got the cube root of 125 to the 4th. Now this is not my preferred way, I'm just saying, but a lot of people do it this way. You still need to prime factor the 125 underneath here, and remember that it's raised to the 4th. So that 125, so I have the cube root of 125, but it's raised to the fourth. So I'm going to convert that 125 to 5 to the third. And so we still have a power to a power. So you multiply and you get 12. So I have the cube root of 5 to the 12th. Then remember, we're going to take this index and divide it into here, which fortunately goes in there nicely. And you get 5 to the 4th, because 12 divided by 3 is 4, and we're back to the 625. So some of you are going to really like that method because that's the way your brain operates. And that's fine. You're welcome to do it that way. But sometimes it's a little bit more complicated to convert it into the radical form. It just depends. So I'm only going to do it way 1, but that is the alternate way. So now I put a cough drop in my mouth, so hopefully I'll quit coughing. Maybe. Okay, so prime factor 32. 32 has a bunch of 2's in it. It is 2 to the 5th. If you don't believe me, prime factor it out. So then I'm going to raise that to the negative 2/5. So the long way would be 2 to the 5 over 1 times negative 2 over 5. So again, these 5's cancel, but if you don't see that, 5 times negative 2 is negative 10. 1 times 5 is 5. Negative 10 divided by 5 is negative 2. But the shortcut would be to just do that. So 2 to the negative 2. You know we can't deal with negative exponents. So if you want the exponent to be positive, you have to push it in the opposite direction. So I end up with 1 over 2 to the positive 2, which is 1 over 4. So then you need to pause the video and do this one on your own. Okay, so I'm going to change 16 into 2 to the 4th, and then that's raised to the 3/4. So 2 to the 4 over 1 times 3 over 4. You have 12 divided by 4, which is 3, or cancel your 4's and you still get 2 to the 3rd. 2 to the 3rd is 8. Done. Okay, so then here's variables added onto it. So one of the reasons why I like, well, sometimes way 2, the second way we did that one problem on the other slide, sometimes I will convert to radical form. Sometimes you have to, but more than often I try not to. So let's look at this one. So if you're used to trying to put it in the calculator and have the calculator do the work for you, it's not going to work once you get to variables. So if you recall, I have a power to a power, and we essentially distribute this power into here. So I'm going to multiply each of these exponents by 2/3. So I have x to the 6 over 1 times 2/3, and y to the 5 over 1 times 2/3. So here I've got 12 divided by 3 is 4. To cross cancel, the 6 and the 3 are both divisible by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. Then the 2 times 2 is 4. So I get x to the 4th. So either way you want to think about it, times. On this one, nothing will cross cancel. You can only multiply across. So 5 times 2 is 10, over 1 times 3 is 3. So I get y to the 10 over 3. What that means is that this is under a radical, and I'm going to have to simplify. This is not, because it does not have a fractional exponent. So this is in front of the radical, this is going to be underneath the radical. So I have x to the 4th, that's out in front, and the y is going to be underneath a radical. Because the denominator in the fraction is 3, it's a cube root, and that leaves us with y to the 10th. So if you remember the index rule, this 3 is going to divide into that 10. So 10 divided by 3 is 3 whole times. So I'll bring out a y to the third. And then 3 times 3 is 9. That leaves 1 left over out of 10. So I'm going to get x to the fourth, y to the third out in front, the cube root of 1y left over underneath. There you go. Now this one is an interesting one because these are both x's. The previous one had an x and a y, but these are x's. I'm multiplying like bases. So remember, when you multiply like bases, don't you add the exponents? So I've got x to the 3/4 plus 5/4. They have like denominators, so I can add the numerators. So I get x to the 8/4, which is x squared. So I didn't have to do any conversions, no prime factoring, nothing. So then I want you to pause the video and do this one. But first, remember when we are dividing like bases, what do you do with the exponents? That's right, you subtract them. But you subtract where there are more. So pause the video. Okay, so 5/3 is smaller than 7/3. So we want to cancel all of these and subtract them here. So these are going to cancel, and I'm going to subtract 5/3. Again, I have like denominator, so I can subtract it. So 7 minus 5 is 2/3. Now, 3 does not divide into 2 at all, and I can't have a fractional exponent as an answer, so I have to reconvert it into its radical form. So I know that we're going to have a radical. The denominator of that fraction is 3, so it's a cube root, and that leaves me with x squared. And that's it. All right, so then we have some numbers here. What you will notice is that this is a different index than this one. So I cannot divide the 27 by the 3 because these are not the same indexes. So it's like they're in two different jails. They can't communicate with each other. So the best you can do is try to convert 27 into the same base as this. Well, I know that 27 is made up of 3 3s. 3 times 9, and the 9 is 3 and 3. So I'm going to rewrite the 4th root of 27 as the 4th root of 3 to the third. And then I'll leave this as the square root of 3. So then I can convert them into their exponential form. So the numerator becomes 3 to the index goes in the denominator, and this goes in the numerator. So I get the index in the denominator, which is 4, and then the 3 goes up here. So I have 3 to the 3/4 over. Then the square root of 3, well, remember the index is 2 and the 3 is raised to the first power. So I have 3 to the 1/2. Now I have like bases. So since I have like bases, I can subtract the exponents, but you want to subtract where there are more. 3/4 is bigger than 1/2. Look at 3/4 of a pizza and compare it to 1/2 of a pizza. 3/4 is more. So I'm going to cancel all of this and subtract it up here. The problem is I have unlike denominators. So you have a choice. You can multiply 2 by 2 to get to 4, or you can just multiply them both together and get 8 and change both of them. The least common denominator is 4, so that's what I'm going to choose to do. So I need to multiply 2 by 2 to make it a 4, so it looks like the other denominator. What I do to the bottom, I have to do to the top. So I end up with 3 to the 3/4, that's a 4, minus 1 times 2 is 2 over 4. Now notice how all of this canceled. So this is technically over 1, but we don't write anything over 1, so I can ignore it. Then 3 minus 2 is 1, so we have 3 to the 1/4, which converted into radical form, because my answer cannot have a fraction, is the 4th root of 3 to the 1st. So you tried this one on your own. So pause the video. Okay, so I am going to convert 32 into a base of 2. For fourth root, 32, as we've already talked about, is 2 to the 5th, divided by the cube root of 2. Then you want to convert each radical into its exponential form. So the numerator is 2 to the 5/4, and the denominator is 2 to the 1/3. 5/4 is larger than 1/3. So just like the previous one, all of this is going to cancel by subtraction upstairs. I need like denominators. 4 times 3 is 12, so I'm going to make them both into 12. So 4 needs to be multiplied by 3, and so does the 5. That's a 3, believe it or not. The 3 needs to be multiplied by 4 to make 12, and so does the top. So I'm left with 2. 5 times 3 is 15 over 12, minus 1 times 4 is 4 over 12. 15 minus 4 gives you 11 over 12. So convert it into its radical form for your final answer. So we have the 12th root of 2 to the 11th. Now I'm not going to make you multiply out to the 11th, so you're welcome. Normally you'd have to. But notice that 12 does not even go into 11 once, so this cannot be simplified. So this is your final answer. And that, my friends, is all there is. So this is a blank page. So enjoy your homework. If you have questions, please don't hesitate to ask.